Hello everyone. Today let's solve the problem number 45. Right? Jump game 2. We have already solved jump game 1. Today we'll be solving jump game 2. Right? So what the question states here? So here we are given a zero indexed array of integer nums of length n. You can clearly see here zero index, right? So 0, 1, 2, 3, 4, 0 to 4. So elements here maximum jumps is 2, 3, 1, 1, 4. They have given, right? So we are initially positioned at nums of 0. Initially we are positioned at nums of 0 here. You can clearly see. So each element nums of I, iterated value of the nums, represents the maximum length of a forward jump. Maximum length of a forward jump means either we can jump one time or either we can jump two, right? Maximum length here is 2 they have given, right? So next step here is, in other words, if we are at nums I, we can jump to any nums of I plus j, where this one, whatever I have said, I plus j less than n, means here if we are given 3 here, either we can jump one step, either we can jump 2 steps, or we can jump 3 steps, but maximum is 3. We cannot jump more than 3. So that's what this states here. So next one is, return the maximum number of jumps to reach nums of n minus 1. So when nums of n minus 1 means last index, right here. So we have to return the minimum number of jumps, sorry, not maximum number of jumps, it's minimum number of jumps to reach nums of n minus 1. The test cases are generated such that you can reach nums of n minus 1. That's fine. So we have to return the minimum number of jumps, that is required minimum number of jumps to jump from 0th index to last index, right? This index to here, this one basically. So that's what they have given in the question. So here you can clearly see first example, second example, they have clearly mentioned here. So let's try to understand the same thing, and also let's try to understand example 2, and then let's discuss the approach step by step, followed by edge cases, and finally write the code and discuss the complexities of the code that we have written, right? Initially let's discuss the examples first. So here let's discuss example 1 and example 2, right? So in the jump game 1, what we did, they had asked whether we can jump from 0th index to last index or not. That's what. And if we can jump to the last index, then we had to return boolean value true, right? If we cannot jump, then we should return we had to return false, right? That was for this one, jump game 1. So in the jump game 2, for this particular question, they have already given that at any cost we will be jumping from starting index to last index. But the thing is, we have to determine the minimum jumps that is required to jump from the first index or the 0th index here, in this case as it is 0 indexed, so 0th index to the last index, right? So that's what they have asked in the jump game 2. Here you can clearly see, from 2 either we can make one jump or two jump here, either we can go here or we can go here, right? So suppose if we jump 2 steps here, from here we can make one step. Here 2 we have, either we can make one step or two step, right? Here one step or two steps. Suppose if we are in the 2th step, we have to go to the next step because we can make only one step here. From one, again here we can go one step at a time, right here. So again 1. So this will be 1 plus 1 plus 1. This will be total 3 jumps, right? So here, instead of going in that way, so if we can go to here, so one step at a time here, then we can make 3 steps at a time here. We can directly jump here. There are several ways to jump from begin to end. So this is the minimal way. You can clearly see here, one step at a time, and this one we are going 3 steps at a time, means one jump plus one jump. This will be 1 plus 1 equals 2. This will be 1 plus 1 plus 1 equals 3. So the minimum in this case, there are several ways that will lead to more than 2 steps, but this is the minimum way. So this is the minimal way to jump from start to end, right? So this we need to return in this case. So in this case it will be 2. Same goes with example 2 as well. This is for the example 1. Let's discuss example 2 here. The example 2, we can jump from here. So we cannot jump to this one at all. If we jump here, this will be 0. We cannot move forward at all. So at any cost, we have to jump to here from 2 to 3, one step, right? So next, either we can jump from 3. We have jumped from here to here. Either we can jump from here to this one, and from here to one step, right? Because we have 1 here. So in this case, it will be 1, 1, 1. This will be total 3. So in this case, what we can do, this will be 3. We can still go in the minimal way. We can directly jump from here to here. 3 steps we can, right? In this case. So in this case, 1 plus 1. Here also, it will take only 2 jumps. So the minimal jump that we can make from start to end here is 2 as well. For this one also, it is 2 here. And for this one also, this is 2 here. So I hope this is completely fine. So next step here is, let's discuss the approach step by step in this case, right? Let's discuss the approach step by step. So here, what we'll be doing in this case, first we will keep track of the jumps, current end, and the max reach, right? So we will keep track of jumps that is being taken, and current end, nothing but the farthest index we can reach in the current jump, and the max reach is the farthest index we can reach overall. So we will be iterating through the array, nums array. In this case, this is nums array, right? Nums equals, so we will be iterating through the nums array, updating max reach to store the maximum index that can be reached, right? So when we reach the current end, we will take the jump and update the current end to max reach. So we have already, it's guaranteed that we will reach nums of n minus 1, means we will reach the last index. That is guaranteed, right? That's what they have given in the question. At any cost, we will reach the last index. That is not the problem, but we need to find the minimum number of jumps that is taken to jump from begin to end, right? So since it's guaranteed that we can reach nums of n minus 1, the algorithm will always find the optimal number of jumps here, right? So that's what here in this case, let's fill the table. Here this is nothing but index here, 0, 1, 2. This one, it is already triggered here, jump. So 3 and 4. Here this is array elements, 2, 3, 1, 1, 4. Nums of I is nothing but iteration. First 2, first second 3, third one is 1, and fourth one is 1, and fifth one is 4, 2, 3, 1, 1, 4. So max reach here in this case, it will be 2, right? We can either go 1 or we can 2. This is 2. Current end will be 0 initially, and the jumps will be 0 as well. Here in this case, nums of I 3. So maximum reach here is, we can directly go to 4 here, right? From 3 to 4. 1, 2, 3. We can move one step at a time. This will be 1, this will be 2, this will be 3. Totally we can just move to 4. Max reach is 4 in this case. Current end is 2, and current jump is also 1, because from 2 we have jumped only one step here, right? Current end is here 2 in this case, right? So this is fine. So next step here is, max reach will remain 4 itself from 1. The next element here, max reach will remain 4 itself. The current end in this case will be 2 and 1 itself, right? So this will jump is triggered here in this case. We don't have to calculate nums of I max reach here. In this case, current end will be 4 and jumps will be 2, right? So next, let's go with the 3. So this one, third index 1. This one, sorry, this one here. Just give me a second here. This one. So here in this case, 1, the maximum reach is again 4 itself, right? The maximum reach is always 4 itself in this case. So maximum reach we have here is 4. You can clearly see 4, and the current jump here is 4. We can reach from 1 to 4 here, right? Current jump is to 4, and the jumps is 2 in this case, right? So I hope this is clear. So again, here let's consider the final one here, final element in the array, 4. So this will be in this case 4 itself. Current jump will be 4. It remains same, and the jumps, it will be same. We will consider the previous one itself, 2, 2. So this is fine. it will remain 2 itself. In this case, we have to return the last value, nothing but we have to return 2 in this case. So this is the minimum jump, that is minimum jump that is required to jump from start to the end. So this we will be returning the value that is present at the bottom right cell or the last cell that is present in the jump column, this one jumps. So this we will return as the output. So the final output, the result we got here is 2. So here the output that we got here is 2, and the output they have mentioned in the question for the example 1 in the question is also 2. So the approach works absolutely correct in this case. So this is the approach that we will be going with, mainly the greedy approach, right? So I hope the approach is completely clear. Now let's start writing the code, and after writing the code, I'll just let's discuss the complexities of the code that we have written. So let's initialize the variables jumps, current end, and max reach. So as we had discussed right during the approach. So here I'll just go with let jumps equals 0, and current and also initially this will be 0. So and finally max reach will be 0 as well in this case, right? Initial step, initialization. So next we have to iterate through the array until the second last index. We saw this one, right? So simple for loop, I'll just give here let I equals 0, I less than length of the nums minus 1, nums dot length minus 1. Here let's increment the I in this case. So within the for loop, what we will do, we will update the maximum reach to store the farthest position that can be reached from index I. Here in this case, max reach equals let me give mat.max of. So here max reach comma I plus nums of I in this case. So I hope this is clear. So if we reach the current boundary, nothing but the current end, we need to jump in that case, right? So how can we articulate that one in the form of code? If we reach the current end, right? So here I can just give here I equals current end. We are just comparing. If we reach the current end, current boundary or the current end, then what we need to do, we need to jump, nothing but we have to increment the jump count and move the boundary to the max reach. So when I say increment the jump count, I just have to give here jumps plus plus, and also we have to move the boundary to the max reach. So I'll just give here in this case current end have to move to the max reach, right? So I'll assign this one to the max reach itself I have considered. Yeah, this is fine. So final step here is we have to return the total number of jumps that is needed to reach the last index. In this case, jumps, this one, right? This one, jumps, we have considered variable. So we have to return the jumps here in this case. So let me return jumps here. So this is it for the code. Let me format the code once and hit the run button. I hope this works. Let's see. So why this is not showing? Yeah, here you can clearly see the sample test cases are getting passed here in this case. So let me hit the submit button quickly. Hope this works. Let's see. So here you can clearly see all the test cases are getting passed here, right? So just give me a second here. This got stuck here. So yeah, all the test cases are getting passed here. So the code works absolutely correct in this case. So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is this one, greedy algorithm. We know that one, right? So we went with greedy approach. So the overall time complexity would be here big O of n in this case. So let me give here the overall time complexity would be big O of n. Why? Because we are iterating through the nums array once. You can clearly see here we are iterating through the array once, updating max reach and current end. We are updating the max reach and current end. You can clearly see here, right? So max reach and current end in big O of 1 per iteration. For single iteration it is big O of 1, right? For individual element. So overall time complexity would be quite obviously big O of 1, big O of n, sorry. So what would be the space complexity here? The overall space complexity would be big O of 1, because we are making use of only few variables here, jumps, current end, and max reach, which doesn't require any additional space in this case. So overall time complexity would be big O of n, and the space complexity would be big O of 1, right? So here I hope the solution that we have written, or the code that we have written, is completely clear. For now, this is it. Thanks for watching, guys.